Hello everyone. In this video, we'll be solving a simple problem from the design of gasketed joints. So here you can read the question. A cylinder head of a steam engine is subjected to a steam pressure of 0.7 megapascal. It is held in position by means of 12 bolts. So number of bolts is 12. So a soft copper gasket is used to obtain the leak-proof joint. The effective diameter of the cylinder is 300 mm and we have to find the size of the bolt that are used in this gasketed joint so that the stress in the bolt is not to exceed 100 megapascal. So the step will be we'll have to evaluate the stress in the bolt and that should be limited or equated to this limiting value of 100 megapascal. So to evaluate the stress we'll have to calculate the load, and to calculate the load, the final load or net load on the bolt will be evaluated using this 9-point way. So if you are observing this K is the gasket factor, we will be taking that gasket factor from data book that I will be showing. And FA we already seen from the previous video. FA is the net external load acting at a single location, and we have evaluated this is the external load, and we are knowing this is the external load per bolt, and this will be equal to the total external load divided by the number of bolt that you are knowing, and the total external load will be created by the internal pressure of the fluid acting. Here steam is there, so pressure is given, which is 0.7 megapascal or 0.7 into 10 raised to 6 newtons per meter square or 0.7 newton per mm square, and that is it is acting over an area that is corresponding to this diameter of this, or the pi by 4 d square area, and the diameter of the cylinder is given 300 mm. So I'll be writing this FES P into pi by 4 into d square, where this P is equal to 0.7 megapascal, or here I am using 0.7 Newton per mm square. Then I will be using the value of D in mm so that its area is coming in mm square. So D should be used as 300 mm. Then I can evaluate this value by substituting these two terms. Then you will be getting the total external load that is acting over this 12 number of bolts. Then you will be getting this value of 49,480 Newton you will be getting. So from this you will be evaluating this FA. So this FA will be equal to this 49,480 divided by number of bolts, since the number of bolts used are 12, and this FA will be equal to 4123.34 Newton you will be getting. So now you are knowing the value of FA to be substituted in this equation. Next you have to take Fi. Fi is the load acting on the bolt due to tightening, and K is the gasket factor that we will be seeing how to take from the data book. So here in this equation, this Fi is the initial tightening load, and that you can use this expression 9.1c in data book, and that is given we have seen in the last video, Fi equal to 2805d, where this d is the major diameter. So d is the major diameter of the bolt, and this is to be substituted in mm so that you are getting the force in Newton. So here diameter we have to evaluate, so I will be using this d as a variable itself. Then you will be getting the value of FIS 2805d as such we will be substituting, and we have to find the diameter d, and remember d is the major diameter. Now we have to obtain the value of this gasket factor K. Here in question it is mentioned that soft copper gasket is used, and according to which we will have to take the value of K that we will be seeing now. So the value of K you can take from this data book page 136, and it is given in 9.1. So you can see in the first column, you can see for the material here soft copper gasket is used. So you can take the value of this K as 0.5 you will be getting. So gasket factor is K equal to 0.5. So now you are having all the equations that is to be substituted in this one. The net load acting F equal to K into Fa plus Fi. So now you are having F is equal to K, which is 0.5 into Fa is 4123.34 plus 2805. All values are in Newton. So D is to be substituted in mm, which is the major diameter. So now we are having the net load, and from this net load we will be evaluating the stresses, and for evaluating stresses you have to divide this net force divided by tensile area, so that we will be seeing now. So now we'll be evaluating this stress, and you are knowing that stress will be found by dividing this F by tensile area, where tensile area is the area evaluated across the weaker section of the bolt. So this K into F, a 0.5 into 4123, you will be getting as 2061.67 plus 2805D divided by 80. And here you have to solve for this diameter. So I will be writing this 80 in terms of diameter. And you are knowing this 80 is the tensile area, or it is the weakest area, and this is evaluated corresponding to the minor or the core or the root diameter. So we have to represent an 80 in terms of this one. Then this is equal to pi by 4 into dc square I can write. But actually here we are having one variable in d, and here another variable dc is coming. So while solving this equation, we will be solving at the end by equating this one to sigma allowable, so that you can evaluate the diameter. But here you are having two variables d and dc. So here you will be converting this dc in terms of d. So you are knowing the core diameter is always lesser than diameter, the major diameter, and it comes between the range of 0.84 to 0.9. So here I will be assuming the dc is equal to 0.84 times d, and based on this assumption will be verified at the end of the problem. So here I am taking dc equal to 0.84 d, then I will be getting the stress induced sigma t equal to 2061.67 plus 2805 d divided by, now I will be having a variable in terms of this dc, that is equal, dc will be coming in terms of d. So this will be having pi by 4 into 0.84 times d the whole square, and this should be lesser than or equal to the 100 megapascal. Since I am using all values in Newton and in mm, so this should be lesser than or equal to the sigma allowable, and the sigma allowable value to be substituted is the property which is given. The allowable stress should not exceed 100 megapascal, means 100 Newton per mm square. I will be substituting 100 only. So now I can solve this equation. So if you are looking here, a variable or the square of d is coming in this term, and this d is coming, so you will be getting a quadratic in form of d, and finally you will be getting a quadratic that is equivalent to 55.42 d square minus 2805d minus 2061.67 equal to, right hand side will be finally 0. You will be getting this equation. So if you are solving, you will be getting diameter in terms of units of mm. So if you are solving this one, you will be getting d equal to 51.34 mm. So now we have to select a suitable bolt from this isometric thread from data book for this obtained value. So by solving this d, you have obtained a value 51.34 mm. So if you are looking onto this table that is corresponding to this basic dimensions for the profiles of isometric thread, that is table, this is actually table 9.8, which is given in page number 143. Then you can find that the next nearest standard value nearest to this 51.34 is 52 m. That means this isometric thread you can select or designate it as M52, and you can you have to set the pitch. So here different pitch coming are 5, 4, 3, 2, 1, 5. So you can take any value. So you will take, suppose if you are taking the value of 5, so you are selecting, finally designating the bolt to be selected as M52 divided by 5, and it is having a core diameter of, or the minor diameter which is coming in this question, that is, oh sorry, in this table, that is as 45.86, and based on we earlier assumed it as 0.84 times d, and we will be verifying. So dc is equal to 45.86 mm here, according to this standard selected it should have, and we have assumed earlier it is a 0.84 times. Now we will be verifying whether this 0.84 into dc, sorry, 0.84 into this major diameter, that is 0.84 into 52 mm, and we will be evaluating this one a value of 43.68 mm. That means if you are based on the assumption, the minimum diameter or core diameter should be at least 43.68 mm. But the selected M52 by 5 mm is having a core diameter of 45.86, which is more than the required. So this design is safe. So if you can select the other pitches also, whatever pitches you are taking, if you are the taking 1.5, then it is having a core diameter of 50, that is very much greater than this 43. So the design is safe, or you can finally return the answer as the selected bolt is M52/5 for this given application. So this is the solution of this simple problem. So hope you understood, and thanks for watching.